All right, welcome everybody. So yesterday we started relational database management systems, and we talked about our schema design. Today we're going to go ahead and move forward and start with constraints in PostgreSQL, right? So although you may have not noticed it, we were already talking and working with constraints, right? And essentially, what constraints are almost like a check. Think back to object-oriented programming when you guys were creating like your setters, right? You would add some kind of like if-else statement in your setter, and if it qualified, then you would set your setter to whatever it should be. And if not, then it wouldn't set the value to whatever you wanted to set, right? Uh, I like to think of it as if-else statements or almost like rules at the exact same time as well, for what something should be or what it shouldn't be, right? And as I mentioned, you guys already start seeing it with your primary key, right? Whenever we created primary keys, the constraints that you were putting on these attributes were, hey, it has pretty unique, right? And it won't repeat itself, right? And we're going to start off from there for today's lecture, all right? So if you look at my VS Code, I am currently under constraints. I created a directory for my demo, and I have a file that I created called constraints.sql. So if you're wondering where I got this from, that's where it's from. And in this SQL, I'm going to go ahead and start with my table. So just like yesterday, we are going to do drop table if exists.
Hey Roger,
And
we just see the Notepad++.
oh, let me share hmm, run screen three. Can you guys see my VS Code?
Yep, good now.
All right, those are my professor notes. Ignore that. All right. Uh, so we're gonna go ahead and start off with our drop table if exists, as you guys saw earlier, and we're gonna use the scenario of students, right? We're gonna do students, and I want you to also create your table. So create table, and we're gonna say students. Remember to add your semicolon. And for our students, we're gonna start off with our student ID, which will be our primary serial key.
When you get a chance, Roger, can you zoom in 2 clicks?
Oh, of course, thank you for the reminder. Is that better for you guys? Let's move that, shift this over a little bit. And then we're gonna give the student ID or the student table a student name. And the student will be a type varchar. And I'm gonna give it 100 characters since I don't know any student that has that long of a name. And then a student email, right? So the student email varchar will make this 255, just in case. All right, so look at this table right now. The constraints that this table has, we have it with the student ID. That's the first one that you guys were pretty much introduced to, the primary key. And what this is telling me is that the constraints on this primary key are that it is going to be unique, right? Because typically, if we follow the rules of normalization, we don't want to set our primary key that something's going to something that's going to change, right? I saw a little bit of that yesterday. We were setting like primary keys on names of different things. Remember, like the chances of something changing over time, it's pretty, likely. So it's a good idea to just make it into some form of ID, and deserializing or the serial version of it allows it to increment as well using the sequence table. So you don't want to always set your primary key to something that isn't an ID. Um, you can, of course, but it's good practice to use the student ID if you can, right? So it's going to be unique and it's going to be incrementing, right? And not repeating. So these are constraints that the student ID has. Now for a student name right now, the only constraint it really has is a max characters of 100, right? On top of that, because it is a varchar, a constraint is that it's going to be a type string, right, with max characters of 100, right? Now, for the student email, when we think about emails, uh, you really don't want to have the same email for another student. So a constraint that you could add to the student email would be the constraint unique. And I don't remember if we used it yesterday, but this is one of the constraints that you would essentially have, right? And we can insert our table into a database. I have two terminals here open up. One so I can run my SQL, and then I'm gonna have a different one which I'm gonna run my database in. And I'm gonna drop DB in case if I have it, which I do because I was messing with this earlier. Constraints DB. That drops my database. I'm gonna go ahead and create database again. So it's fresh. Create DB constraints underscore DB. Remember, there's two ways of creating your database. You can do it from your terminal, or you can do it inside of Postgres. I'm gonna come into the database and let's see what I have here. As we see, we do not have any relations yet. I have not added my schema or my table into my database. So go back to my other terminal. I'm going to say PSQL constraint DB. Is it with an S? I did do S. Constraints DB. And I'm going to add my constraints SQL file. Just move this a little bit like that. Right. So notice table students does not exist. So skipping the drop table and we create the table. This is just a little recap from yesterday. We can see what I have in here, and I have the students and the sequence table that was created thanks to the serial attribute that I added to student ID. So now that I have that in there, we can try to mess around with this. So we're gonna go ahead and insert into our database. We're gonna say insert into. I want to insert into the students table, and I'm gonna add a student name and a student email. Right. Values. I'm gonna say, I'll use one of you guys. I'll say James, and his email is gonna be james@james.com. Right. Next, we can say insert into. I'm gonna say students. And I will say student name, student email, values. We'll do Gary. And for some reason, Gary decided to use his buddy's name. And when we run this, I'm gonna get an error, right? So we create a table, we insert the first insertion on line 9, we made James. But when it gets to line 10, it's gonna give me an error saying that, oh, my bad, students. There we go. Duplicate key value violates the unique constraint student's email key, right? It realizes that it does have a unique constraint and it's not gonna allow us to add something that's already within our database. And that's, a great way to keep from having repetitive data within your database. All right. Another one that we can probably add within this table, which you guys have probably already seen, is going to be your no, actually we'll cover check first. We'll go through the curriculum. So we have unique, and now let's see how we can do the check. Well, we're gonna say, let's go ahead and comment this out. And we're gonna create a new table. And this is gonna be for our movies. All right. So drop table if exists. We're gonna create movies. Create table. And this table will be called movies. We'll keep it plural. I want to have a movie ID, type serial with a primary key, a movie name, which is going to be type bar chart 255, and an age limit, type int. And the new constraint we're going to talk about is going to be the check constraint, right? So we are able to add some kind of like an if-else statement check here, or like a rule that says that it's only going to take a certain value. All right, so we use the check, and you can open and close parentheses, pass in the data member that you added here. It was the age limit, has to be greater or equal to 0, and age limit has to be less or equal to 18. We add that into our database. And when we try to insert into our movies, we're going to pass in the movie name, pass in the age limit with the values of, we'll say, we're going to make a Python movie, very educational, with a value of 15. And we'll create another movie. This is going to be a little bit different. We're going to make this one the It movie. And for some reason, you have to be 21 for this one. I'm getting an error here because I did not add a semicolon. And when we try to insert into our database, it's going to check the check constraint that we added. And we see here that the new role for relation movie violates the check constraint, right? It failed to insert it due to the fact that it is not less than or equal to 18. All right. And when it comes to the check constraint, there's different ways that we can actually use this. The first one is by doing it very deliberate here. We say less than or equal to from a left or a right limit. But there's also other ways of doing it where we can say something like age limit between 0 and 18. And when we try to run that, oh, there you go. We see here that it still did the exact same thing. It violated the check constraint because the failing rule contains the 21, right? When we switch this back to 18, we see the insertions went all the way through. And then we can select all from movies. And we see that it was added. When we add 21 back again, we're reinserted, it failed. We can check our database and it is no longer present, right? Due to that check. Now, here is one way or a second way of doing the check. A third way is by adding a list of different items that you want to check into. All right, so we can say something like age limit in, and then you pass in parentheses in here, and you can add the different types that you want to check. We can say age limit in 13, 15, or 18. When we run this again, we see that the new role for relation movie violates the check constraint once again because it does not find the 21 within the in parameters that we passed in. But if we change this to 18, we get both insertions, and we can select all from movies. And now we see here that it was added within our table. Right. So we have three different ways of doing it. We have the age limit in. We also have age limit between 0 and 18. And we have the age limit greater than or equal to 0 and age limit less than or equal to 18. Right, so we have three different ways of using the check method, but check is just another constraint here that we can add to ensure that we do not get data that we do not want saved into our database. Do I have any questions of how the check constraint? You're absolutely right, because it is unique, especially with the serial. If you added three different types of data in there, right? It creates the ID for you from start to finish, 1, 2, 3. If you decide to delete, let's say the item on ID 1, that ID will not be repeated. It uses the sequence table to continue with the last value, right? If you guys remember, whenever we check that sequence table, it gives you that last value column and it tells you what was the last value that was used. It uses that as a reference so it can continue incrementing it as we add new data into our database. Any questions whatsoever about the check method for age limit at all? Or the unique value? Okay. All right. The next thing we're going to move forward to is going to be using check with regex. So right now we have a check within our age limit, but we can also use check on something like bar chart. Within our movie name attribute, we probably want to add a unique value in here so we don't have movies that are named the exact same thing. And we can also use something like check within the bar chart. And within this check, we're going to check that the movie name adheres to a specific rule, right? And that rule is going to be a regex. Well, to use regex within our check, you have to use this quick line. I forgot the name for it. If someone can refresh my memory on it, of what it's called, that'd be great. But by using this, you're going to implement the regex check on it. After using your squiggly line, you open and close your quotation marks, a tilde.
Tilde.
Awesome. You
Yeah,
are super
right.
smart. Tilde, right? After the tilde, you're gonna open and close your quotation marks. And within here is where you're gonna do your regex check. Now, for my regex check, I want for the start of my movie name. So I'm gonna use my caret to be A through Z, capital letter. And then after the capital letter, I want to have lowercase a through Z. I want that to be 0 more occurrences. And I want that to be at the end of my string. I don't remember if the asterisk 01, I'm pretty rusty on my regex, but this should be able to give me a check for my string for it to be a capital letter and to be lowercase at the end of it, right? So let's go ahead and run our SQL file. We see both insertions pass the checks that we have created. we see within our movies that Python and it are currently located here. But let's try and break this check. We're going to go ahead and capitalize all of Python. We're going to run the SQL file again, and we're going to be presented with an error. It says that movies violate the check constraint movies name check, and it tells us the role that we filled in, and it is no longer present within our database. All right. Because it is all capital letters, it does not adhere to the regex check that we created here on line 16. Do I have any questions about the regex check?
That one follows the same syntax as regular regex, right? We just look that up.
Correct. There's some great websites out there. I recommend regex 1. That is my favorite one. But it should follow the exact same syntax. Regex 101. There we go. Yes, James.
I noticed you didn't have to import regex to do this.
That is correct.
Okay.
I don't know how it knows that, but I did not have to import regs. You are correct.
Cool.
I'm assuming it comes with any other questions before I move forward. Okay. The next constraint we're going to talk about is going to be the not null constraint, right? So by default, Postgres, whenever you do not add a value, it's going to set something to null. And we're going to see that in action. We're going to create a new table, drop table if exists. This is going to be product, create table product, open and close parentheses. We're going to add a product ID, type serial, primary key. We're going to do product name, type varchar, 100 characters. And then we're going to make the product to be unique. And then I'm going to add quantity of type int. And I'm going to add a check within this quantity where I want the quantity to be greater or equal to 0. All right. Let's go ahead, run the SQL, drop table, create table. I can select all from product. I have my product ID, product name, and quantity. Now let's add some actual data in here. We're gonna say insert into. I'm gonna insert into product. And the only thing I'm gonna insert right now is gonna be the quantity with values, and the quantity I'm gonna add is gonna be 20. Well, when I run this, it's gonna pass. It's gonna say drop table, create table, and it's gonna enter in here. And when we select all from product, we see that I was able to successfully add something in here. We have a product ID with the quantity of 20, but notice that there's nothing within my product name. And that's because they're, by default, it'll make it null if you do not add a value. So to prevent that from happening in your database, you want to use the not null constraint. And when we use a not null constraint and try to run our SQL, we're gonna get this error that says no value in column product name, right? And it violates the not null constraint. All right, it was able to realize that we did not add a value within the product name, which keeps you from adding or not adding data that you probably want to have in your database. All right, so by adding product name, we're gonna make this grilled cheese makers. And we can run our SQL again. I'm getting an error here for Oreo cheesemakers. Type integer.
Use the product ID instead of product name.
Oh, thank you. I get tunnel vision. Run it again. Drop table, create table. We insert it successfully into our database. We can select all from product. And I now have my product groceries makers with the product ID and the quantity. Once again, if we try to if we don't add quantity in here, it's still gonna succeed. We see that quantity is 0, so we should probably say maybe like not null, right? Or we can also use something different like default is 0. Where if we run our SQL, even though we didn't add something in there, by default, it'll add our quantity to 0 in here within the quantity field. All right, so we have different ways of doing this. We can either say not no, or we can say default in the event that someone does not have anything within that field. What are your questions in regards to the not no constraint?
Well, pretty much just it just means like it has to have like an input in that field, correct?
I'm sorry, I didn't hear.
Oh, sorry. So the not null pretty much says like you have to have an input for this field. It can't be like empty or whatever. It's pretty much what it does.
Correct. It requires you to have some kind of input to put it into your database. You know, if there's information that you need to have for your users, you would want to have the non-null to ensure that if they don't input something, it's not just blanked in your database.
Okay.
Juan?
Do we have to put the default after the check, or can we set a default without a check? Number one.
That's a great question. You can set the default without the check. All right. So if we run this, we see insert in here. We still did not add something within our values for quantity. And then when we run this, we still see that quantity still has 0. Now you still want to check, right? Because you know, what did they add some ridiculous number within your database? So it's always good to add checks within your fields to ensure you do not get input that you do not want, right? Especially if it's like, let's say you don't have a default and you have your check to be quantity of 0, to be greater than 0. And if we add quantity in here and someone tries to add 0 in here, we get that error that they did not add something. So it's always good to have checks in here to at least get some kind of value. And if not, we can always have a default value in there in the event they don't add something for it.
And then one final one, this might be out of scope for these errors that we keep getting. Is this gonna somehow translate, or we're gonna go over translating how that goes into code so that we can present it on the screen for a user to see?
Yes. So your constraints gonna tie in once we start Jingle next week and we start talking about validators, right? The validators and the constraints kind of go hand in hand, and you'll get to see what happens when someone tries to put an input into your database that does not match what should be matched there, and we can give some kind of customized error message to say, hey, like you need to add something in this field, or it has to be a type this or in this format, right? So it will go hand in hand. We will be able to use error messages in PSQL, PostgreSQL, QL is going to be able to transition into Django very well. I also believe, if I am correct, that you can do something like default 0, and at the very end, you can do your checks, right? Check quantity to be greater than 0. Let's remove this default. And then run the SQL again. Notice here that when I run the SQL, I still get an error message saying that I failed the check. The check doesn't have to come right after the field that you're trying to do it. If you guys would like, you can do your checks at the bottom. Maybe this will make a little bit more sense if I did something like this, where let's go ahead and do the movies one again. I can set the check for movies at the very bottom. I can say check movie, put a comma here. I can run the constraints. And notice that I still get an error for the Python one because the check was still valid, even though it didn't come right after the movie name. So that's personal preference, whether you want to have to check immediately after the field itself, or you want to put all your checks at the very bottom of everything. Both are going to work. I like to have it right after the field, so I know like where it goes to. But the check is not limited to just be within that field. Cool. Let's put that back. All right. So let's go ahead and comment this out. And now what I am going to do is let's get the information from the store. Actually, I'll just make it in here. Let's create. We're going to do drop table if exists. And we're going to do games. We're going to build off on what we talked about yesterday with the games table. We're going to say create table if, sorry, not, we're going to say create table games. And for the games table, we had a game ID, serial primary key. We had game title. We're going to say varchar 50. We had a quantity of type int, and we had a price of decimal, and we'll say 42. Now, building off on yesterday's table and what we learned about constraints, someone talked me through what we want to add in regards to constraints with our game table. If you guys were creating this table for your own application, what kind of constraints would you as a developer want to have for your game title?
I want it to be unique.
Okay. We want it to be unique.
And add some regex in there, like you
Yes.
added above.
Yeah, we
So-
probably want.
Oh, sorry. Go ahead. I was just gonna say, that you could, have it not null.
Yeah, we probably want to have some input here. We don't want to have some kind of data in our database that does not have a game title, or that doesn't really tell us too much. Right. So we probably want to make this a unique not null field with some kind of regex to ensure that we do not get some random input, right? And for the game table, we want to ensure that it kind of reflects the data within our game.csv, right? If we look at our game.csv, This is the type of input that we're getting. So if whenever we create our regex, we probably want to ensure that we can get capital letters, lowercase letters, numbers, and even special characters like we see here. We have the colon. If we don't account for spaces, we might get. So we'll probably have to take that into consideration. Besides the game title, what kind of check do we want for our quantity?
That it's greater than or equal to 0.
Say that again, I'm sorry.
That it's greater than or equal to 0.
Yeah, maybe greater or equal to 0. Do we want a limit to the quantity or no limit?
That's if there's like 100 of the same games in stock or something.
Sure, we can say 100. I mean, we can make some makeshift constraints for now. I'm just messing around with it. It's it's your application, right? Whoever your client it requires from you guys, it's up to y'all, right? So maybe like from 0 to 100. Anything else that we might want to add to the quantity?
Not null.
Okay, we can say not no. Not no.
Would it have to be default 0 after like just like you'll do like an integer check, make sure that it's greater than or equal to 0, but you want the default to be 0.
Yeah, we could do that in the event maybe the user or whoever is adding data into here forgets to add something in here. Maybe want to default to something. So we all right. So we have the quantity. How about price?
I would say also greater than or equal to 0.
All right. Maybe check, greater or equal to 0. Do we want to set a limit to how much someone wants to charge for their game?
Let's go with regular gaming prices, like what is it, like $69.99?
Sure, we can say greater or equal to 0 or less than or equal to, we can say 69.99. Awesome. Well, let's go ahead and start adding these constraints to our table. So on the game title, we have we want to make this bad boy, we want to make it unique. It should be not null. And we are going to want to add a check in here. Check. And this check is going to be a regex. We want to check the game title and compare it to our regex. And this regex is going to be a little bit complicated, and we'll talk through how it works. We want the start of our game title to be either A through Z, capital letters. Let's look at the CSV. They're all capital letters, but we can also give the option of lowercase A through Z. We want to be able to also have maybe numbers if it starts with a number. I don't see anyone in here, but let's start with it. But we can say numbers. We want to be able to take into account spaces. So we'll put a space in here. Underscores. Some hyphens. And maybe also do colons.
Oh.
Right? And then apostrophes, right? So hyphens, colons, apostrophes, and in the event, sorry, they add backward slashes. We'll want to check that on our game title. And is there anything else for game title? We have the unique, the regex, and we have the not no. Okay, so our game title seems to be good to go. For our quantity, we said we want it to be a check where the quantity is maybe we could say between 0 and 100, right? We also said it shouldn't be not null, and give it a default of 0. Our decimal needs to have a check as well, where the price is, oh, I did this wrong too. Quantity between 0 and 100. Our price should be between, we said 0 and 69.99 with a default of 10. Let's keep this consistent. Put the default in. And let's see how this works. I'm going to say copy games from the path is going to be from data. All right, because I'm currently within the constraints, data right above it, data game.csv with CSV header. And let's see if this works. I'm gonna close up this tab and try to run this. We see notice table games does not exist, skipping, drop table, create table, and then copy 10. We'll say select all from games. And we successfully added our entire CSV for games, right? We don't have anything that is below or greater than a certain number. We were able to grab our entire list of game titles, and we have our game ID. Do I have any questions of how this was achieved?
Yeah, for your default, can we put that after the checks if we put all the checks at the bottom, or the default has to be on the same line that you're declaring this stuff for, like price and decimal, for example?
That's a great question. Let me get rid of these. I'll keep commenting here. Let's move these checks to the bottom. The defaults, if I'm correct, they do have to be in line. The reason why the check doesn't is because notice within the checks, we are telling it what it has to check, right? Whereas the default, we don't. We just say default 10. Well, what's default 10, right? The check here, we say check. What do we want to check? I want to check quantity, and it's between 0 and 100. Yes, Jacob.
Yeah, just to make sure, when you did a decimal, that's 4 digits and then a decimal place of 2. Is that correct?
Correct.
Okay. That was making sure. Thank you.
All right, so Juan, I saw your hand up. Was that in regard to the question you asked earlier? Okay, let's see if we can run this. I might get an error maybe because of commas, but we'll see how it works. We see drop table, create table, copy 10. And we can still select all from games, and it's still the same, right? Let's put a comma here just in case. But we're able to add the default, kept it online, and the checks were at the very bottom. Once again, the check is able to be at the very bottom of the entire table. It doesn't have to be in line because the check specifically tells it what we're checking for. Right, we're checking quantity, we're checking price. The default does not have that option. All right, so that has to be in line. Yes, James.
When you do the check between like 0 and 100, is that is the same as greater than or equal to? Does it include 0 and 100, or is it excluding?
It's including the 0 and 100, I believe.
Okay.
Let's, where can I show that? Maybe on the quantity. We have between 0 and 100. Let's change quantity. The max one here is 50.
It's inclusive for SQL.
Check price between games does not exist. What are you talking about?
That's probably where my questions come in. On 46, you didn't end it with a comma. I was gonna ask if we needed them or not.
It looks like we did, which is weird because earlier it didn't give me that error, and now it is. All right, so I added the comma. It looks like that was the issue, Juan. It's a little confusing because I did it earlier without the comma and it didn't give me an issue. But now it's yelling at me. But notice I changed the price. Oh, let's put that to 100. I'm gonna change the between for price from no the between for quantity from 0 to 50 because in the game CSV the quantity, the max quantity we have here is 50. And when we run it, notice I still copy 10. And when I select games, it's still being able to grab the Minecraft. So even though it's saying between 0 and 50, it includes the 50 in the check. Cool. Awesome. I'm sorry, I can't use fancy words like exclusive and inclusive. Like Guillermo, English is my second language. So honestly, just saying exclusive really, confuses me. So do bear with me. I do have an accent as well, as you can tell. So I'm new to these words. Do I have any questions so far of how this was achieved, guys? Besides what you guys already asked. Awesome. We're gonna take a pause here. It is 9:49. We're gonna reconvene at 10:30 and finish the second part of today's lecture. We just covered constraints. Upon returning, we're gonna go over relationships and how the one-to-one, many-to-one, and many-to-many work with our actual schema. Sound good? There is an assignment for the constraints. So between now and 10:30, let's work on the assignment. I'm gonna go ahead and pause the recording. We're gonna go ahead and pick up from where we left off. So we just finished talking about the different types of constraints that you might encounter. We're gonna go ahead and move forward into relationships and how that works, right? So we're gonna use the example that we talked, or that is actually in the README, and we're gonna go ahead and draw it out. I have TO here opened up, and the first one that we're gonna talk about is gonna be our one-to-one relationships, right? The first one on the example is employees and Social Security, right? A one-to-one relationship is as follows, where you have one employee who has one Social Security number, right? That Social Security number can only belong to one other person, and that person can only have one Social Security number, right? There is no additional ones, there's no special occasions, it's just a one-to-one. Now, how does that look like actually within our code? Well, going back to our VS Code, I have here my relationships.sql that I created, same directory as where I had my constraints. And we're gonna go ahead and draw out this schema for our employees. We're gonna do drop table. If exists, I'm gonna name it employees. And then I'm gonna create my table. Nothing new here has changed. this employee is going to have an employee ID, which is going to be of type serial, primary key. And I'm going to have an employee name. It's going to be of type bar chart with 100 characters. And I want to make sure that this name is not null. We're not going to add unique because obviously we can have multiple different other employees with the same names. So there's our employees. Next, we're going to do our social security numbers, which will be drop table. If exists, social securities, create table, social securities. And what this is going to have is going to be a social security number ID. Same concept like employees, where it's going to be a serial primary key. And it should have a social security number, and we're going to make it type bar chart, mainly because of the hyphens that are in the name. And it's going to have a max character of 11. As we already discussed, the social security number has to be unique and it cannot be null. Right? Let's not forget our semicolons. Oh Lord, where's all this? Okay. And let's clear this up. I'm gonna say PSQL. I want to go into my constraints database and I want to run my relationships.sql. We're gonna see table employees does not exist. So it skips the drop table, it creates it, and then it creates my social security table as well. Go ahead and clear this up. I'm gonna go into my constraints DB. And then I can do select all from employees. I get my table with employee ID, employee name, select all from social securities, and I get my table with social security number and social security number ID. Now, this is cool and all, but how do we actually make the connection between both of these? Well, the way that is done is by the way of a foreign key, right? And what we're going to do is connect them by adding that foreign key within our social security number. So after line 12, the way that you assign the key is going to be by calling the foreign key method. I want to say, hey, I want a foreign key. What should my foreign key be? Well, as of right now, there's nothing in social securities. So I'm going to go ahead and add it in here. And that foreign key is going to be the employee ID that belongs to whatever employee I'm assigning this social security to, right? This employee ID is going to be of type integer, right? To reflect the serial primary key that belongs to that employee. And now going back to my foreign key, I'm saying, hey, I want a foreign key. That foreign key should be my employee ID that I have defined. And I want it to reference, right? Make sure it's plural references. I want it to reference the employees table. And within this employees table, I want it to reference the employee ID. Right? Now, if we run this, did I miss before? Oh no, I think I need a comma here.
You have a semicolon at the end of line 14, your foreign key line.
Oh, thank you. 2 eyes are better than 1. All right. So that runs. I see drop table, create table, drop table, create table. Awesome. I still don't have anything in here. So let's go ahead and add some insertions in here. We're going to say insert into employees. This only is going to take an employee name. The value for this employee is going to be myself. And I want to insert into social securities. Social securities is going to take the employee ID that's supposed to be the foreign key. It's going to take in a social security number. The values will be as follows. the ID that I want to reference is going to be the ID of Roger, which since it's going to be the very first item within our database, the normal ID will be 1, right? Being the first entry. So I'll add 1. And the social security number, it is of type bar chart. So I'm going to open up my quotation marks here. And I'm going to say 222-22-2222. Right? This is now my actual security number. And now, when I run this, we get an issue here. It says cannot drop table employees because other objects depend on it, right? Why am I getting this error? Who can guess why?
Because of the dependency from the foreign key.
Correct, right? So when it runs my code from top to bottom, it's trying to drop the table, right? The first command here is drop table. And it can't do that because it's saying, hey, like this employees table is dependent of Social Security, right? Social Security is using whatever belongs from the employees table. So if you drop this, there's going to be some kind of error. This might get corrupted. There might be an issue with this whole Social Security table. So I can't drop it, right? So I need to do something to avoid this functionality. Something has to happen if I delete my employees table. And what should happen is if I don't have an employee, then I shouldn't have any Social Security numbers, right? No Social Security number exists without an employee. So the way to get around that is by using what's called the cascade method, right? So at the end of the drop table of existing employees, all you have to do is type in cascade. And what that tells Postgres is when you try to drop employees, it's gonna say, hey, there's a dependency in here, like I can't drop employees. Oh, okay, you're using the cascade method. That means I have the authority to go ahead and drop whatever is dependent of this table. So it would drop both of them at the exact same time. By adding that, I can go back here, I run it, and we see, notice drop cascades to the constraint of Social Security employee on table of Social Securities, and it goes ahead and drops the table. It recreates it. It's able to drop the security one as well. It creates as well, and we see 2 insertions. Well, let's look at what our employees is giving me. I do select all from employees. I have the employee ID of 1 with my employee name. And then if I do select all from Social Securities, I see my Social Security number ID being 1. I do have an employee ID column here, which has the value of 1, which is essentially referencing my employee, and then the actual Social Security number. Now, so far, this is still not adhering to the one-to-one relationship, and I'll show you why. If I were to go down here and do inserts into Social Securities, employee ID, SSN, and I want to create a new Social Security, nothing is stopping me from adding the same person to have another Social Security number. If I were to come down here, I rerun my SQL. We see here there's no issues. I have 3 insertions. And when I select all from Social Security numbers, we see here that I have another entry for another Social Security number, but still referencing the exact same employee. Therefore, it's telling me that this employee has 2 Social Security numbers, and that does not adhere to the one-to-one connection. So the way to fix this is by going to that foreign key and doing something as simple as unique. Right? So when I try to rerun my SQL, you're going to notice that I'm going to get an error for this 3rd insertion. It's going to say that it violates my unique constraint and that employee ID 1 already exists, right? So when I check my Social Security table, I only see 1 Social Security number in here that belongs to just my 1 employee, being employee ID number 1. And this is how you create your one-to-one relationship. Do I have any questions of how we achieve this? Yes, Owen.
So for your inserts for social securities, you manually put in the value. How would you be able to pull your specific employee value? Because I feel like that's very inefficient, because like then you're gonna have to go find that employee ID every time and then put whether it's 1 or 247, you have to manually put that in. So how can you automate that?
Are you talking about inserting into the database, or are you talking about like retrieving the data back for us to see?
So like on line 18, specifically put in employee ID value 1. How would you be able to automate that? Like I would imagine you'd have to add a column in either social security and like social securities to do say employee name. Like it just seems very inefficient to just manually put in the value, because kind of how we utilized when we're putting in massive amounts of data from a CSV file, updating that serial value at the end to make sure it doesn't overlap. In a similar fashion, couldn't you just put in like just one line, insert into employees, and then make the employee name, and then as well as inserting their social security number into social securities?
I think I understand where you're getting at, and I feel like it will become a little bit more apparent once we start working with Django and implementing
Okay.
Postgres into Django.
Like I guess to simplify my question is, you're having to manually insert that employee ID value into line
into
18.
lines 18 and 19 when I
Exactly.
create that table.
And that seemed very inefficient.
Yeah, so that's why we use certain frameworks like Django or React. There's gonna be more efficient ways of talking to our database and actually implementing data. Here, it's a lot more deliberate. And going back to what I said earlier, once we start seeing Django and the powers that it has for you, you're gonna realize how much more efficient it will become. Right? Does that make sense?
Yeah. So for now, just we'll have to manually input that employee ID to add any values in a one-to-one relationship.
Correct.
Okay. Thank you.
There might be a better answer. I'll give it Francisco and see if I can get back to you with that. Sound good?
Yep.
Awesome. Anybody else?
Hey, Roger.
Hey, Lynn.
Just to piggyback on Owen's comment there, or question there, it really is like we learned CSS and then we learned Bootstrap. We learned JavaScript and then we learn React. We're learning SQL and Postgres, and then we're going to see how Django uses it, and it's going to alleviate some of this stuff that is, to your point, difficult and maybe not the most efficient thing in the world. Every tool uses things, and every technology that's been created abstracts some things and was developed to solve a problem of yester generation. And then we forget what that problem was because, we forget what it's like not to have a telephone, how about a touch screen on a cell phone? I mean, before we text, we used to write, letters to people. It just changes. So we're learning the basics right now.
Sweet. Thank you.
Yeah, to even piggyback even further from what Len said, you're gonna realize once we get to Django and we start talking about models of like, you're gonna think to yourself like, well, why did I learn SQL if I'm doing the models differently in Django, right? When you create your fields, it's gonna be a little bit different of how Django talks to Postgres. And because they all kind of come in like hand in hand. Like, so you have to know how it works with Postgres so you can learn how to do it with Django, right? There'll be more efficient ways of doing stuff once we get to Django. And you might think to yourself, well, everything I just learned from Postgres is pretty much obsolete. Not necessarily, right? There will be more efficient ways of doing it. You kind of just have to learn both ways to really understand the concept. Is that good? Awesome. All right. So we just covered our one-to-one relationship. And This was probably the easiest one to understand. The next one is going to be a little bit more. Actually, the schema version of it will be easier, but as we dive into many-to-many relationships, it's going to get a little bit more complicated. All right, so for our example, for our many-to-one relationship is a university and students. So I'm going to go ahead and I'm going to make our students. And we're going to have multiple students here. And the way the many-to-one relationship works, I know it sounds a little bit redundant since we've been doing it for a while now. It's going to be our university. And the many-to-one relationship works as follows. We have multiple students who belong to one university, but only one student can have one university, right? So this university has multiple students, but every individual student can only belong to one university. Going back to the explanation of the luggages, right? So when you go to the airport, you might have 3 or 4 bags of luggages, right? But those bags don't belong to a random stranger in the airport. They only belong to you, right? So a many-to-one relationship is multiple students to one university for all, right? So how does that look like in code? Well, let's go ahead and comment out this. And we are going to create our university and our students. So we're going to say drop table if exists. We're going to create our universities. And I'm going to add the cascade method right off the bat so we don't get any issue. We're going to create our table called universities. This university is going to have a university ID, which is going to be of type serial primary key. And a university name type bar chart. We'll say 70. I'm gonna say unique, not no. I don't know if multiple universities named the same, so it should be unique from my understanding. Right. So we have our university. Next, I'm gonna create, or I'm gonna do drop table if exists. Students. Create table. Students. And the student table should have student ID, type serial primary key, student name, type bar chart. We'll say 50. It doesn't have to be unique, but let's say it's not null. And then we're gonna do well, let's look at it, right? We have our universities, we have our students. Let's run our tables in here. I have a syntax error somewhere around here, students. What am I doing here that does not like? Is it this? There we go. It didn't like that comma. So we have the drop table, create table. I'm gonna add cascade in here. Actually, no, we won't need cascade right now. Now on this example. All right, so we have our tables. We can check out our database. Select all from universities. We have university ID, university name, good to go. Select all from students. Awesome. Right. Now, what you're going to see is that the many-to-one and the one-to-one relationships are actually extremely similar. And there's only one thing that separates them. And if you learn one-to-one, you practically already learned many-to-one of how to do it within Postgres. So coming down to my students, I'm going to say foreign key. I'm assigning a foreign key in here. Let me add a comma here before I get an error. Foreign key. The foreign key that I want Well, I currently don't have one in here, so let's create one. The foreign key that I want to reference should be the university ID that's currently within the university's table. So I'm going to say, hey, my foreign key is with on line 33, university ID. The references for that is going to be in the university's table. Within that table, I wanted to reference the university ID. Earlier, for the one-to-one, oh, I forgot to put the type here for university ID. University ID is a type integer. All right. So earlier, the way that we ensure it was a one-to-one relationship is by ensuring that the foreign key that we were referencing was a unique value. But here, you're going to see that that doesn't really make a difference here, right? Let's ensure that this is working. I have no errors. I knew it. There we go. All right, so it's doing what it should be doing. We're going to create a university and a couple of students here. So we're going to say insert into universities. I want to create a university name. The values will be as follows. It should be code platoon. And then I'm going to create some students. So insert into students. Should have student name and university ID. The values are as follows. And I'm going to have, let's say, Sam. He belongs to University of ID 1. Let's create some copies here. We have Sam. We're going to say Jesus, Haley, and Jacob. Right? Now we come down to our terminal, run our SQL file. Everything so far so good. The cascade's working. We have the 5 insertions, 1 being the university, 4 for the students. We can come down here. We can select all from universities. Our university is in here with an ID of 1. And then we can select all from students. And we now see that our table holds 4 different students, Sam, Jesus, Haley, and Jacob, and they all belong to the University of 1, right? Do I have any questions for many-to-one relationships? James.
So I feel like this actually might be what Owen was talking about. If you have to input, and again, maybe this is not valid. If you have to put each time that the university ID in 38 to 41 is 1, what's the point? Wouldn't the result be the same even if you didn't have that foreign key line on 34? Because you're inputting university ID as an integer in each line.
Well, let's do some selection. This is a tomorrow class, but I can show you how this works. We can do select all from students where let's say join universities. So select all from students, join universities on students.university ID is equal to universities.
University spelled wrong on after join.
Yeah,
you got an extra Y in there.
I got fat fingers, my friends. Join universities
Gotcha.
on student.university ID. And then where it's equal to universities.university ID, where student.university ID is equal to 1. Whereas you want to, you remember reference a column Okay, I see what I did. I misspelled university again. University. Okay, I think that's good. Where students, I'm sorry, there's a lot. Okay, I think that's good. There we go. Right. Uh, and this is what we get back. We get the student ID, the student name, and then we are able to reference both of them being university ID, same thing with the university name. Does that give you a better picture of how it's supposed to look like?
Yes, it does. Thank you.
Okay. I know it's a little complex. You'll understand a little bit more tomorrow once we start talking about it. Okay, we just haven't gotten there yet. I know this might look very foreign. We're taking it a step at a time and slowly building to tomorrow's lecture. Yes, Gary.
So I was just wondering, so the one-to-one relationship is just because it has a unique foreign key, and then the one-to-many is because they share a foreign key?
Correct.
Okay.
And I just want to piggyback on Gary's questions. I know earlier you did the unique key when you were doing the one-to-one relationship. In the
Mhm.
curriculum, it doesn't have that unique. It just has the ID. It shows them both as the primary key instead of using unique.
Where for the one-to-one?
Yeah, on the one-to-one.
Let me go to curriculum. I see one-to-one.
So like your employee ID would be primary key, and then it got the social security and it has employee ID as primary key as well. And it got the social security number as the unique. So
Oh,
I guess my question is, do it work both ways? That's my question.
I see what you mean. So it could work both ways. Uh, there, it kind of goes back to the normalization and principles of how you want to format your data. Uh, it's it looks better, it's better formatted if you were to put the employee ID into Social Security, right? Because the employee is kind of like the main entity, and then you have the Social Security that's relying on the ID that belongs to that employee, right? Social Security cannot have anything else besides an employee, right? But employee can have multiple other things like Social Security numbers, might have timesheets, might have like other things, right? So it's better formatted if you put the employee's ID into Social Security and have that as a foreign key. And then the reason why I don't understand why the README doesn't have a Social Security number ID in there, but you want to use a specific ID for each table. And the reason for that is because once we move into other frameworks, you will see that the frameworks, specifically Django, they automatically give every model their individual unique ID, right? You won't even have to do this where we do like primary key is this. Like it automatically makes a primary key. It knows that, hey, this is a new model. This is going to have a primary key, which is going to be a serial version of it, right? And it'll do that formatting for you. So because of that, we teach it the way that we do. I don't understand why the README is like that. I could bring that up, but thank you for that question. Anybody else? Awesome. So difference between many to one and one to one is the enforcement of what is unique, right? So the one to one, it shouldn't be able to have multiple people having the same security number. So we had to make that foreign key unique. But here, right, in this scenario, we have the students and university. The university should be able to have, a connection with multiple other students. So we don't want to make this university ID unique, because if it becomes unique when we try to create another student that belongs to a university, it's going to give us an error. Like, hey, there's already a student that attends here. You can't attend it. But that's not correct. That's not how the functionality should work between a university and a student. Right? We should be able to have multiple students that can belong to one university. Sound good? Okay.
I just have a quick question about the syntax for foreign key. So like, I know like you didn't actually include the university ID when you made the universities table, so that's just saying like this is gonna belong. Oh, you did. Okay, never mind. I didn't see it at first.
I apologize.
Gotcha.
Yeah.
No, you're good. No, I get it now.
Awesome. We good? Can we move forward? Or any more questions? All right, right on. So next, we're going to talk about the many-to-many. All right, so we have our one-to-one employee social security number, our many-to-many. Looking at the README, I believe the many-to-many, it's the same scenario with students. Okay, this time it's courses. All right, so we have our students. Let's go ahead. I'm going to go ahead and copy this, and we're going to make the students over here. We are going to have courses. Right, and then let's make multiple of these. There should be multiple courses. One might be math, one might be English, so on and so forth. We want it so that students can belong to multiple courses and courses can have multiple students. Right, that is the goal. Unfortunately, it's not as simple as just connecting both of these, and we can kind of see how that works, right? Let's go ahead and comment this out. And I'll show you what I mean. We're going to create our two tables. I know we already have a student one. We'll just do it real quickly. Drop table if exists. Students. This already done this, so we can keep seeing it. Create table, students. This student is going to have a student ID, serial, primary key. And then we should have student name for our char. We say 50, not null. All right, so we have our students. Now we're gonna have our courses. So drop table if exists, courses, create table, courses. And our course is also gonna have a course ID and serial, primary key type, a course name. It's gonna be type varchar, and we'll say 100. And it can't be null. Right. Let's add cascade here before I get an error later. Right. So we have our two tables, and if we were to make this relationship similar to how this looks like, it would be nice if we could do something like this, where we said course ID is going to be type int, foreign key, courses ID, references. We're going to reference the courses table with course ID. And here we could do student ID, type int. If this a foreign key, student ID, references, students, student ID, right? At first glance, you see this and you think to yourself, well, this makes sense, right? We should have multiple students that can belong to multiple courses, right? And we should have courses that can belong to multiple students. But the issue with this logic by looking at this is that currently I have a student ID, right? With a foreign key from courses, and courses has a foreign key from students. And if I try to create, let's say if I want to add the student to another course, right? That student, it will essentially be a different version, right? Why? Well, because the student ID, it would be different, right? Therefore, the student ID isn't the same, so it's not unique. It's not that same student. We essentially might have, what it looks like in a database is that you have multiple different people named, Alice Martinez, whatever name you want to come up with, right? The student ID needs to be unique, right? For every individual student should have their own ID. So if we wanted to have a student to be part of multiple courses, we would have to recreate the table, but it won't work because the student ID is unique. Therefore, in theory, it's multiple different students, right? So with that logic, the many-to-many relationship like this does not work. And I bring this up so you guys understand why we have to make a third table. So we're gonna go ahead and remove the course ID and the student ID. And let's look back at our TL draw sketch, right? At first glance, you would think it would work something similar to this, but actually what you would have to do is create a different table that tracks what students are in what courses. This table will be of type diamond. It will say course students. Let's zoom out a little bit. Actually, let's expand this while we look at the TL draw. Let's delete that. Delete that. Right. And the way that would be is this student is currently attending this course. This student is also attending the exact same course for this one. This student might be attending a different course for, whatever math might be. This was attending this one, and so on and so forth, right? And this allows you to keep track of what students are attending what course without making weird dependencies and not having to create multiple different other students, right? Because we can't do that due to the fact the ID is unique. Every single student needs to be its own unique student. So what it's done is that you create another table where you keep track of ES1.
Sorry, I was gonna see if you're gonna get to it, but I'm pretty sure looking at this, the second table is gonna take in or take count of one item. Excuse me. Take count of one item essentially and consistently point to a specific different course. So it'll basically say
Correct.
this group, it belongs to this one over here, right?
Correct. We're about to see that in action, but you're on the right track. Yes. So let's go ahead and see how that looks like in our schema. So we currently have two tables, students, and we have courses, and we need somewhere to kind of link them together. And the way that we are going to do that is by creating an additional table. We're going to say drop table if exists. This table is going to be called course students. And I'm going to have to add cascade to our courses table. If not, I'm going to get an error. I'm going to try to drop tables. We're going to say create table. This table is going to be called course students. And what this course is going to take is course student ID, right? It's going to have its own ID, serial primary key. And it's going to have the student ID of type int. And it's going to have the course ID of type int, right? Now, the way that you connect them with foreign keys is very similar to how we've done everything else so far, right? Using the foreign key. So after you create your student ID and course ID within this table, you're going to say foreign key, and you're going to connect your keys. First one's going to be student ID. The reference is going to be to the students table, and it's referencing the student ID attribute. Next, we're going to connect the course ID. It's going to reference the courses table to the course ID field. All right, let's add our semicolons so we don't get an issue. All right, and let's see how that works. Okay, Jelenami, we see, okay, syntax error at or near. So whenever we try to create tables, I'm getting, is it because the comma? Let's try that. There we go. It didn't like the commas. Right. So table students did not exist, so it skips drop table, create table. Same thing for all my other tables because they had yet to be created. It skips the drop table portion, and essentially it's just creating all my tables right now. We can go to my database, and I can say select all from students. My table's in there. Select all from courses. Courses is in here, and then we can say select all from course students. And we got it working. Now let's actually create some items in here. We're going to create students first. We're going to say insert into. We'll have our students. It should only take, I believe, just a student name. Values is going to be Tristan. I'm going to copy and paste. We'll add, we'll say 5 students. We're going to say James. We'll say Ryan. I don't know if Gary's hiding, but we'll say Gary. And then we're gonna say Jacob. All right. So we have our students. Now we're gonna create our courses. We're gonna say insert into courses, course name, values. We're gonna have Python, and we'll have one more course. This one is going to be JavaScript. All right, let's see how that is looking so far. Run the SQL. We are successful with our insertion. We can select all from students, and we get students Tristan, James, Ryan, Gary, and Jacob with their own unique IDs. We can say select all from courses, and we have Python and JavaScript within our courses. As of right now, nothing is really linked to itself, right? We have yet to create that link between the students and the courses. We have yet to add any course students. So let's see how that works. We're going to say inserts into course students. Course student takes a student ID and a course ID. Well, looking at this ID, I see the first one's going to be Tristan. So let me not get ahead of myself. Let me add the course student attributes, course ID, values. The first value we're going to add here, it's going to be the student ID. So I'm going to say, Tristan, you're going to attend Python. And let's start copying these values. All right. And no, actually, you're attending JavaScript as of right now, right? Because JavaScript is, of course, ID 1. And you only took JavaScript. James is of ID 2. He's going to take both Python and JavaScript. Next is Ryan. He's only taking Python. Next is going to be Gary. He's only taking Python because he couldn't take the heat from JavaScript. And then finally, Jacob, you are going to take both Python and JavaScript.
You got James taking Python twice.
Oh, thank you. I appreciate it. Now, we can go ahead and run this. Successful in all my insertions, knowing the cascading is working. We can now go to our course students, and we see student IDs, course IDs, and their own unique course student IDs, and this shares the relationship between all of them. Let's bring this over here. We have student ID. Next is going to be our courses and the relationship between these. Right? Like a span or TL draw. We have all students here. We have the courses. Let's box them up. Diamond. And then for the other courses, we're going to say a circle. Right. So we have Tristan here, ID 1. Oh, okay. I don't know if I can draw straight. Right, Tristan is at student ID 1, and he is attending only JavaScript. We then have James. He's attending 2 different courses, so he appears twice, Python and JavaScript. Brian appears once. He's only taking Python. Gary appears once. He's taking Python. And then finally, we have Jacob, who is taking 2 courses, right? Both being Python and JavaScript. Right, and this is how the relationship works. Now, if Jacob needed to drop a course, right, the way that he drops it is by removing him from the course students table, right? If we didn't have that, it would make it very difficult to try to remove him from a course. And you're gonna see this in Django, where if the relationships aren't correct, you might lose certain data for certain people, right? And to avoid that, we have that third table between both of these to ensure we don't lose either the courses or the students when we try to drop people from courses, right? This allows us to remove them from the course students. They no longer share that relationship between amongst each other. And that is all shown through this one table. Do I have any questions for many to many? James Byers.
Yes, is it will you be able to show a way to get names in there? So you ain't just looking at numbers. Is there a way to bring the student name over with the student ID in that courses underscore students?
Yes, and we'll see a lot more of that tomorrow. So I'm not drawing some SQL or typing in SQL and stuff. But essentially you could do like select all students from like, course ID, whatever. And you can like tell it specifically like, hey, give me back the names of all the students that currently belong to course ID 1. Give you all the information for that student, right? Thanks to that relationship. So there will be a way of doing that, and we will talk a lot more in depth tomorrow about it. I like that question. I just don't want to like overstimulate you guys with more information. Anybody else besides Jam Buyers?
Can I just see the code a little bit more?
Yeah, of course. Right, we have 3 different tables: the student table, the course table, and the table that links them together, right? Where you actually form the relationship. Right. So, small recap: for a one-to-one relationship, you only have the 1-2 tables that share that relationship, and then you want to make that foreign key that you have added to the table unique to ensure you can't repeat it. Many-to-one, same concept except the unique constraint. And then many-to-many, you need that third table where you link the relationships. Right? All of them using the foreign key method that references that location of it. Any other questions, guys? All right. Let me go ahead and stop sharing. I'm going to pause the recording. Or actually, I'll pause the